So here we're going to talk about the heat equation when you're changing the temperature of a single phase of matter. So we just went over a couple problems relating to the specific heat of water, where in order to increase the temperature of 1 gram of water by 1 degree Celsius, one requires 4.184 joules. Now that's a constant. That means the specific heat capacity of water is 4.184 joules per gram degree Celsius. So how much energy would it take to increase m grams of water by delta T degrees Celsius? This is our heat equation down here, where we just take the product of mass, specific heat capacity, and change in temperature. So this is within a single phase of matter. So we are not going to be talking about temperature changes and phase changes combined yet. So we're just talking about changing the temperature within a single phase of water. So, and liquid water does have a different specific heat than solid water, aka ice, and gaseous water, aka steam. So they do heat up differently. Okay, so Q is equal to MC delta T. You're going to be using this whenever you're talking about changes within a single phase of a substance. So whenever you're talking about those temperature changes. And when you're talking about phase changes, you take the moles and multiply by the enthalpy. So we're focused on these ones here today. So here is the heat equation again, where Q is energy, M is mass, C is specific heat capacity, and delta T is the change in temperature. Now, technically, Q can have a positive or a negative value, but I like to think about it as absolute. Makes a little more sense. When you're doing calculations, however, be careful and make sure you are communicating. If energy is added, it's gaining energy, Q would be positive. And if something was losing energy, Q would be negative. It would have a negative value. So I normally like to think about it in terms of using the absolute and including the language. So if you say, for instance, I earned $20, your net change in money is positive 20. Or I spent $37. Your net change in money is negative 37, but you are incorporating that into the language. So by saying I spent it or I earned it. So there's a triangle. Now recap, I got a PVU table. The biggest mistake people make is I ask how much energy something takes or is required to do so-and-so. And people will give me the temperature change. They're like, well, 10 degrees Celsius, that's how much energy. Well, that's not a unit of energy. The units of energy are joules, kilojoules, calories, kcal, megajoules, millijoules, et cetera, et cetera. So make sure you guys pay attention to what the question's asking. And I sent out that reference sheet with all these properties, variables, and units tables on them. So this is the equation. This is what we're supposed to calculate. How much energy is required to increase 25 grams of liquid water from 10 degrees Celsius to 14 degrees Celsius. Given the specific heat capacity of water is 4.184 joules per gram degrees Celsius. So we want to solve for the value of Q. Q is equal to M, which is mass, C, which is specific heat, and delta T, which is temperature change. My mass is 25 grams. My specific heat capacity of water is 4.184. And my change in temperature is 4 degrees Celsius. So be positive 4 because I'm gaining the energy, going from 10 degrees Celsius to 14 degrees Celsius. So calculate my value, 25 grams times 4.184 joules per gram degrees Celsius times 4 degrees Celsius is 418.4 joules. Okay.